So let's look at Kp. Kp, the equilibrium constant for gases, P meaning pressure, is the same as Kc, where C is concentration involving solutions with water in them, or Ka, equilibrium constant for an acid. Kp is exactly the same, except with gases, where you're talking about pressure, you've not got any water or solutions involved. So it's slightly different, but the concept is the same. Let's have a look. A-level 2015 version 0.5, so specimen 1 essentially, paper 1. Okay, what have we got? We've got CO2 and 3H2O, 3H2 making methanol, CH3OH and H2O. We've got the initial moles, 1 mole of carbon dioxide, says in the question, 3 moles of hydrogen. It doesn't say that there's anything made yet initially of methanol or water. But then it says at the end there's 0.86 moles of methanol, so therefore 1-to-1 ratio there must be 0.86 moles of water. And there must be therefore 0.86 moles of carbon dioxide used up, because 1 mole of carbon dioxide makes 1 mole of methanol. So I've made 0.86 moles of methanol, I must have made 0.86 moles, so it must have used up 0.86 moles of carbon dioxide. Now, 1 mole of carbon dioxide reacts with 3 moles of hydrogen. So if I use up 0.86 moles of carbon dioxide, I must use up 3 times 0.86, which is 2.58 moles of hydrogen. I need to work out how much is left over, or made, in the equilibrium mixture. Starting with 1 mole of carbon dioxide, used up 0.86, subtract the 2, I've got 0.14 moles of carbon dioxide left in the mixture. 3 moles of hydrogen, used up 2.58, subtract the 2, 0.42 moles of hydrogen left in the mixture. Didn't start off with any methanol, made 0.86 moles, that's how much I've got. Similarly for water or steam, started with nothing, made 0.86, I've got 0.86. Now this is what you've got to do, you've got to work out mole fractions. Let me talk you through this. Total moles of gas. If I add up the total moles of gas, I've got 2.28 moles of gas. If I add up 0.14, 0.42, 0.86 and 0.86, 2.28 moles. I need to scale that to be 1 mole in total. So instead of 2.28 moles in total, I need to scale it down to 1. So I need to divide through by 2.28. If I scale down everything by 2.28, my mole fraction of carbon dioxide, 0.14 divided by 2.28 rather, is 0.61. Similarly, 0.42 divided by 0.28 is 0.184. 0.86 divided by 2.28 is 0.377, and similarly for the water. Now I've scaled it down, so the total number of moles in the mixture is 1. They are called mole fractions, 0.061, 0.184, 0.377, 0.377. Now, what I've got to do is I've got to work out something called partial pressure. The partial pressure is the pressure that's come from that individual gas, and that depends on its fraction. So say, for example, if the total pressure was 500 kilopascal, as it says in the question, if half of the gas were carbon dioxide, half times 500 would be 250 kilopascal, except I've not got half of the gas is not carbon dioxide. 0.061 out of the 1 mole in total is carbon dioxide, so I multiply 0.061 times 500 and I work out the part of the pressure, the partial pressure that's come from carbon dioxide is 30.5 kilopascal. Similarly, the fraction of hydrogen is 0.184 out of 1 mole. So I multiply 0.184, that's the fraction that's hydrogen, by the total pressure, 92. 0.377 of the 1 mole in total is methanol. Multiply that by 500, 188.5 is the pressure that comes from the methanol, and the pressure that comes from the water is similar, 0.377 times 500, 188.5. If I add up all those partial pressures, they will altogether they will come up to 500 kilopascal. Now write an equilibrium expression, but instead of concentration square brackets I put pp, which stands for partial pressure. It's exactly the same. Partial pressure of things on the right multiplied together, divided by partial pressures of things on the left multiplied together, and I still need the 3, the indice 3 raised to the power of 3 for the partial pressure of hydrogen, because I've got 3 moles of H2. Just like if I had Kc, I'd have, or Ka, I'd have square brackets raised to the power 3 because I've got 3 moles of them. Plug the numbers in and I end up with 0.0015. That's my Kp. What are its units? Well, its units, like Kc and Ka, change. We need to work them out. So Kp, what have I got? I've got a partial pressure of methanol times the partial pressure of water. I've got 2 partial pressures on top. Pressures are measured in kilopascal. Kilopascal times kilopascal. And on the bottom, I've got 3 pressures. Partial pressure CO2, partial pressure of H2 times partial pressure of H2 times partial pressure of H2. I've got 4 kilopascals on the bottom. Cancel top and bottom, end up with 2 kilopascals on the bottom, kilopascal squared on the bottom, or kilopascal to the minus 2.